In this case study, I'm going to look at how you calculate the motion of a proton in an electric and magnetic field. In particular, I'm going to have a wire, which you see along here, with a current I coming out of it, and flowing in it, of course. And we're going to have a proton somewhere nearby, starting off at some distance x from there, and moving upwards with some velocity v. And we're going to see where it goes. Now what's happening here? Well, because we have a wire with a current, there's going to be a magnetic field, and the magnetic field is going to curl around it. So using the right-hand rule, if the current goes up here, the magnetic field curls around in this direction. So you get the magnetic field coming out of the screen on this side and going into the screen on this side. So let's set up some coordinates. We'll have x in this direction, y out of the screen, and z up there. So this object is starting at position x0, let's say, and moving along the z direction. Now there's going to be a force on the object, and if you remember, the force on a moving charge is equal to its charge, its velocity vector across the magnetic field, plus the electric field in this case. Now there is no electric field, so we can ignore that for the moment. So it's going to be equal to QV cross B. So V vector is upwards here, a B is into the screen. And so we can use the right-hand rule for this. If you remember, whenever you have a cross product, you curl your fingers from the first thing in the cross product to the second one. So we're going to curl our fingers from the V into the B. Let's see if I can draw that. So that would be a hand like this, with the thumb disappearing behind. So you curl your fingers from pointing upwards to pointing into the screen. So that's going to tell you there's going to be a force in this direction. And so it's going to curve around. But then as it curves around, the V is now going to be in this direction. B is still into the screen, so the force is now going to be in this direction. So we should expect some sort of arc or curve to go on here. It's going to be a bit more complicated because the magnetic field is not uniform. If there was a perfectly uniform magnetic field into the screen, then the object would just go in circles, a so-called gyro radius or cyclotron. However, in this case, the magnetic field gets stronger when you get closer, and which is going to change the radius of curvature. So it's going to be a bit complicated. We're not going to be able to solve it by calculus. We're going to have to use a computer and do it numerically.